Easy lesson today. It's the law of cosines. So you've already got Pythagorean's theorem memorized. And Pythagorean's theorem is for a right triangle. And it says that a squared plus b squared is equal to c squared. So what the law of cosines does is extend that and allows you to figure out, well, what about when the angle is obtuse? Or what about when the angle is acute? How do we find it? And the cool thing about the law of cosines is, since the cosine is actually negative in quadrant 2, like in this triangle right here, the terminal angle would be in quadrant 2. Since the cosine is negative in quadrant 2, you would have minus a negative, and that's actually what allows this side C to be a little bit longer for that problem. So the following is the proof of the law of cosines, and first of all, let me show you where these numbers come from. If I were to take the sine of angle C, that would be y over b, and if I were to take the cosine of angle C, that would be x over b, and so here's your y, b sine C, and here's your x, b cosine C. And if I were to then find the distance from point B to point A, and I can find that distance using the distance formula. So the distance formula says that, and in this case the distance is c squared is equal to the difference in the x's, so that would be b cosine C minus A squared plus the difference in the y's, that would be b sine C minus 0 squared, because b is at the point A0. I would end up with c squared equals b squared cosine c squared minus ab cosine c minus ab cosine c plus a squared plus b squared sine squared c. And then if I were to factor out the b squared that's right here, and I'm going to take the a squared and move it to the front, a squared plus b squared times cosine squared c plus sine squared c, and then I take these two pieces and combine them into 2 minus 2ab cosine, that's supposed to say c right there, cosine c, and then we know that this is Pythagorean identity cancels to 1. I end up with a general formula, a squared plus b squared minus 2ab cosine c, which means that actually if you had any triangle that was not a right triangle, you could work it out by splitting it with a altitude, making it into two right triangles and solve both of them, but it could take a lot of trig to get there, and so having this formula just makes it a lot easier. You use law of cosines in two cases. One is the side angle side case. If I wanted to find the length of side x, I would say x squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 60. And so that's 25 plus 64 minus 2 times 5 times 4, which is 40. So x squared is equal to 49, and so x is equal to 7. Also use law of cosines in the side case. So let's say we had a triangle, and this side was 3, and this side was 4, and this side was 6. I wanted to find angle x. My equation would be 6 squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of x. And so now in this problem, you actually have to solve it. And so I'm going to square everything first. 36 equals 9 plus 16, 25 minus, and that's 6 times 4, 24 cosine x. You just have to be careful with your order of operations here. Your next step is to subtract 25. And so you get 11 equals negative 24 cosine x. And 11 over negative 24 equals a cosine of x. And notice this is panning out correctly because this triangle appears to be obtuse. And so I'm going to have a negative number when I'm looking at cosine because if I take the inverse cosine of a negative number, I end up in quadrant 2. So second cosine 11 divided by 24, or negative 11 divided by 24, and I end up with x is equal to 117.27 degrees.